Hello everyone and welcome back. My name is Mr. Cobalt and today we are going to be going over another problem involving how to find the empirical formula. Generally these problems are going to give you information regarding the different elements that are involved in the compound. Sometimes they'll give you the grams of the elements involved in the compound. Sometimes they're going to give you the percentages. So in this problem, they're giving you the percentages. And so again, the goal is to always take what they give you and get it to moles. And then once you're in moles, you can set up your pseudo formula with the moles in your formula. And then from there, you figure out what the ratio is. And then you make sure that that ratio is in a whole number, the whole number ratios. So let's get started on this one. So here it says a laboratory analysis of aspirin determines the following mass percent composition. So we have 60% carbon, 4.48% hydrogen, and 35.52% oxygen. And then they ask you to find the empirical formula. So we're trying to find the empirical formula for aspirin. Okay, so now that we're given these percentages, you can see that the percentages pretty much add up to 100%. So this is all that's involved in aspirin. So what you're going to do is, since you know what the percentages are, but you need moles, you can convert the percentages into grams if you assume 100 gram sample. So they didn't tell us how much the sample is, so we can assume anything we want. And to make our lives easier, if we assume 100 grams, since we have percentages, again, percent means per 100. So if you assume 100%, then you can take the percentages and just write them as grams, because 60% of 100 grams is 60 grams, right? So I'll have 60 grams of carbon, right? And then I'll have 4.48 grams of hydrogen, and then I'll have 35.52 grams of oxygen. So now that I have the grams of each of these, I can convert to moles using their molar masses. So I can now take the grams, 60 grams of carbon. The molar mass of carbon is 12.011 from your periodic table. So I could put 12.011 grams of carbon on the bottom and then 1 mole of carbon on top. So then I can calculate that out in a moment. And I can do the same thing for hydrogen and oxygen. So I can multiply this by the conversion factor of the molar mass. So I'll have the atomic mass of hydrogen is 1.008. And then in molar mass, it's going to be grams of hydrogen. And then that's equal to 1 mole of hydrogen. And then the grams, I forgot to cancel out. The grams of carbon cancel out. The grams of hydrogen cancel out. And then finally you have oxygen. So we can do the same thing with the molar mass of oxygen. So the molar mass of oxygen is 16 grams per mole. I have grams on top, so I want to put 16.00 grams of oxygen on the bottom, 1 mole of oxygen on top. So grams of oxygen cancel out. So now what I can do is I can just calculate the moles of each one. So I have 60 divided by 12.011. That's equal to 4.995. So I have 4.995 moles of carbon. I do the same thing with hydrogen. So I have 4.48 divided by 1.008 equals, and that gives me 4.444 moles of hydrogen. And then I do the same thing, the last thing. I'm going to have 35.52 divided by 16.00 equals, and that gives me 2.22. So that gives me 2.22 moles of oxygen. So now I have my moles of each one. So now I can put the moles in my pseudo formula. So I'm just going to take the moles that I got and just put them in my formula like I normally would. So here I'll do carbon first. So 4.995, and then I have hydrogen. So that's going to be 4.444, and then oxygen with 2.22, right? So, so now I have my moles in my formula, right? But these, I don't want like decimal number moles. So now I'm going to figure out what the ratio is with these with regard to one of them, right? So I can see the relative amounts with regard to one. So the way you do that is you divide by the smallest one, because the one you divide the smallest becomes one, and then the others are going to be related to that one. So then you find a ratio with regard to that particular one. So since oxygen has the smallest one, you divide all of them by the smallest one for oxygen. And that's going to give you a ratio of each of these to oxygen. So 2.22, and that's going to simplify, at least with oxygen, that's going to give you a whole number 1 with oxygen. We'll see what it looks like here. It looks like here we'll get a 2. I'm not sure about that. That maybe, that's close to 5. We'll see what we get with that one. So if I get my calculator, so let me get my calculator really quick. So that's going to be 4.995 divided by 2.22 equals, and I get 2.25. Okay, so I get 2.25. We'll write that down, 2.25 for that one. This is going to be 2, or very, very close to it. So we'll just write that as a 2, and this, of course, is 1. Now, this cleans up nicely, so I have a 1 to 2 ratio and a 1 to 2.25 ratio, right? So now I have this, so it's looking better. But so now I have a ratio of 1 to 2 and 1 to 2.25, and I don't want to change that, but I do want to clean up this a little bit. And the great thing is, you'll notice that the 0.25 here, if you recognize that, you should recognize it as 1/4. So here I have 2 and 1/4. Okay? So now, if I recognize that as 1/4, that's a fraction that I can get rid of by multiplying by 4. So I can multiply by the denominator. So now I can get rid of that 0.25 or 1/4 by multiplying by 4. But to keep my ratios that I have, I multiply everything by 4. So then what happens is I get, if I multiply this by 4, this becomes 9. So I get C9, multiply that by 4, and that becomes H8, and that becomes O4. And this now is my whole number ratio, my lowest whole number ratio with regard to the empirical formula. So this is the empirical formula for aspirin. Okay, so the lowest whole number ratio. And now let me remind you that the empirical formula is not the same as the exact molecular formula, so that could be different. But this is the lowest whole number ratio that I can get for aspirin. Okay, I hope this is helpful, and I hope this clarified a few things. Please let me know what you think in the comment section. If there's anything else you want me to go over, if you like this video, like it, share the video, subscribe to the channel, and make sure that you ring the notification bell, and so that way you get notified by any other new videos that I put out. Thank you for joining me, and I'll see you next time.